So far, so good. Okay, so which models could represent the solution? So we have 35 times 12. You guys worked this out using what method?
Box method.
Good. So we have 30 and 5 and 10 and 2. Can you tell me your partial products?
60, 350, and 10.
Wait, hold on. What goes here?
300.
300.
50.
Okay.
60. And 10.
Okay. So let's go through each one and see what we have. So it has 10 times 30. Did we do that?
Yes.
30 times 2. Yep.
Yeah.
5 times 10 and 5 times 2. Does A work?
Yes.
Yep. Let's look at B. It looks like we're skip counting by 35. So we skip count by 35, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. Did you guys, when you get this, add this up, did you get a final product of 420?
Yes.
So would B, good, thank you, Erin. So would B be a good example?
Yes.
Yeah. Let's check C. Did we do 3 times 1?
No.
3 times 2? Okay. C is not it. And is D?
No.
No. D does not have all the partial products either. What about E? We have 10 times 30, 10 times 5, 2 times 30, and 2 times 5. Does E work?
Yes.
Yes. Okay. So when you get a question like this, write it out yourself so you have in your brain like what it should look like, what it should be like, and then just take your time to check everything carefully. Okay?
Okay.
Cool. We're gonna jump down to number 2. And basically you need to solve these to tell if they are true or false. So go ahead and work out A on your whiteboard for me. Work out A.
What is A? I can't really see it.
It's 271 divided by 3 equals 93.
Yep, I'll write it for you here. We have 3 and then 271. Does that help, Erin?
Yes.
Okay. Go ahead and work that out. Okay, let's do it together. Can I start with the 2? No, because it's too small. So I get 27. 3 times what number gets me 27? 9. Do I have anything left over?
No.
No. Then I bring down the 1. Does 3 times anything give me 1?
No.
So what do I put here? 0. So what is our remainder? 1. So on our paper it says 271 divided by 93 divided by 3 is 93. Is that what we got? Did we get 93? No. So we would check false. Okay. Okay. The next one I want you to try is, we'll do D, which is 5,608 divided by 8. On the paper it says that they got 71, but I want you to solve it to see what you got. Let's go over together. Can I start with the 5?
No.
No, I need to make it bigger. So 56.
7.
8 times 7 gets me 56, Nathan?
Yes.
Good. Do I have anything left over?
No.
And then I bring down the 0. So what I have here is I have the number 0 that I'm working with. Does 8 times anything give me 0? No. So I put a 0 up here. And we have another 0. Now I finally bring down the 8.
1.
1. 1 times 8 is 8. Do I have a remainder?
Remainder 0.
Remainder 0. So would you say that D is true or false?
False.
False. They got 71. What did they forget to do?
They didn't add the 0.
Yeah, they forgot to do this middle part. So this would be false, okay? Now, if this question was asking you something about partial products or partial quotients, what would your partial quotients be for this? 700 plus just 1, right? Yeah. Those would be your partial quotients, okay? Let's go to the next one. Okay. A formal garden has 3 sections of colored tulips. Each section has 162 tulips. How many tulips are there in all? Are we going to multiply or divide? Multiply. Good job, Memphis. So we have 3 times 162. So there's 3 sections, right? One section's over here. That has 162 flowers. One section's over here that has 162, and over there. So we're adding them up, and we know that repeated addition is multiplication. So go ahead and work this out on your whiteboard. You only need 1 and then 3. Okay, go ahead and work that out. Tell me what your partial products are for these 3 sections. What's this first part? 300.
100.
Okay.
And 6.
Okay. Could I do this mental math? Yeah. 300 and 180 is 480. 480 and 6 more is, Colin? Good job, buddy. 486. Good.
Yay.
Awesome. Let's take a look at number 4. Dan multiplied this number by 4 and got the incorrect product. Find the correct product and explain what he did wrong. So automatically we know we have to multiply, so what are we going to draw? Box model. So we have 4, and then we have 4 numbers here. So that tells me I need 4 boxes. Okay, find your partial products for these boxes. What do we have here? 4,000, good. 2,000.
240.
Okay, so what we need to do now is compare it to Dan's partial products. He has 12, do we?
Yes.
Okay, so put a check mark there. He has 240, do we?
Yes.
We have 2,000, does he?
Yes.
Yes. What number is he missing?
4,000.
So if you were to say, hey Dan, you did something wrong, what would you tell Dan? What did he forget to do? Yeah, you would say Dan forgot to do 4 times 1,000. Okay? How do you feel about this question?
Easy.
Good job. Good, good. Thank you, guys. And then to find the product, the final product, you would add up all your partial products. And what did you get for your final product?
6,252.
What is it? 6,252. So it is similar to the product Dan got, but it's going to be 4,000 off because he forgot that one part. Okay? Let's go to the next part. Number 5. a group of musicians earned $570 at a concert, and it was divided equally among 6 musicians. How much did each musician earn? So what's the equation we're going to do?
570 divided by 6.
Yeah, divided by 6. To fill in this model, you're going to do your 6 here, just like your equation here, with 570. Okay. Can we do 5 divided by 6? No, we got to make it bigger. So 6 times what number gets me closest to 57 without going over? 9. What's 9 times 6? 54. How much do we have left over?
3.
Then we bring down our 0. 6 times what number gets me 35? Do I have a remainder? No. So I'm going to take my quotient and put this in a partial quotient. So take this 95 and write it in expanded form. So I would have 90 and I would have 5. Okay? Okay. Just tell me what you would do for number 6. You would do what?
1,500.
Yeah, you would do your box method and work it all out. You guys are really good with that. Here, we have has the boxes for you. And what is it asking you to probably put in all these spaces?
What the numbers are.
Yeah, our partial products. Awesome. Okay, let me go to the last page. We got time to talk about this very last page. A farm distributor packed 2,650 melons into boxes. Each box can hold 8 melons. All the boxes are full except for one box. How many full boxes are there? So what do we need to do? Are we multiplying or dividing? Dividing, yes. There are 2,650 melons and 8 can go in a box. So we need to find out how many full boxes there are. Go ahead and work it out. This will be our last time because we're running out of time today for our lesson. Let's do this together. Can we start with the 2? No, we got to make it bigger. 8 times what number gets me closest to 26 without going over? 3. What's 3 times 8?
24.
Good. How much do we have left over? Then I bring down the
5.
awesome. 8 times what number gets me closest to 25 without going over?
3.
3. What's 3 times 8?
24.
Awesome. How much do I have left over?
5.
Good. Now what?
Bring down 0.
Okay. 8 times what number gets me closest to 10?
1.
1. 1 times 8 is 8. So we have 2 as our remainder. Right? Is that what you guys got?
Yes.
Good. Okay. So if we have this many melons, how many boxes are going to be full?
331.
Okay, there's 2 melons that are left over, but they need to go to the store to get sold. So how many melons are going to be in their own little box? 2. So let's answer the questions. How many melons are in the boxes that are not full? 2, because that is our remainder. Good. How many boxes are used to pack this many melons? How many boxes?
331.
But hold on. There's a box that has 2 in it.
32.
332. Okay? Don't let that trick you tomorrow.
Wait, we're taking this exact test.
Yeah, so this is Form A.